Hello friends, my name is Manoj Chaudhary and welcome to this session on applications of derivative. So already in my previous videos we covered two important applications of derivative. The first one was finding the equations of tangents and normals using derivative, and the second application was all about finding the velocity, acceleration and the jerk using the derivative. So right, and this is the application number 3, which is related with the finding approximate value of the function. So we want to find approximate value of function using derivative. So right, this is very interesting thing. We can find out the approximate value of any function. So the function may be algebraic, trigonometric, exponential, logarithmic, inverse, or any kind of a function that is known or unknown to you with values given, so that you can find out easily its approximate value. See, I am using the word approximate, not the equal. So let's try to see why the word is approximation plays a role in this article. See, this is not the symbol for the equal to. Equal to is very form, LHS is equal to RHS, but I am cautiously using this symbol approximation. So right, so the reason, let's try to find the reason behind it. So since this is the application of derivative, you know the fundamental principle, first principle, I am talking about it's a first principle, and which is the definition of the derivative. According to the first principle, the derivative of the given function f dash of x is nothing but a special limit h tends to 0, f of x plus h minus f of x divided by h. This is nothing but the definition of the derivative, or using first principle we say this is nothing but a simple derivative. We derived so many standard formulae using this first principle derivative formulas, right? Okay, then this is the simple derivative in which x is a variable. What if I put x equal to its exact value a in this? That is nothing but derivative at point. So f dash of a is equal to limit h tends to 0, f of a plus h minus f of a upon h. So simply I am substituting this value of x is equal to a in this formula. So here I substitute everywhere x is equal to a. So this is the ordinary derivative, right? A general derivative, but this is the derivative at point x equal to a. Now the interesting thing is there is a symbol limit h tends to 0 involved here, and what is the meaning of this h is tending towards 0? So the meaning of this h is tending towards 0, or h is approaching towards 0 means it is h value of h is gradually approaching towards 0. It's not exactly equal to 0, but this tells us it is approaching towards a. It may be from left or right. So let's say somewhere there is a 1, then it is taking something value 0.9, 0.8, then 0.5, 0. Let's say 3, 0.2, then 0.1 and then 0. So h may be somewhere here. So the h is approaching towards 2. It is not exactly equal to 0. So h is not equal to 0, but it is approaching close to the 0. Or it may approach towards 0 from this side also, but let's consider any one of this value from this region, and if I consider 0.2. So we can easily express the 0.2 as 0 plus 0. So it is very close to the 0, but it is not exactly equal to 0. So we can say this is approximately equal to 0. So right, and if I increase the scale, this becomes 0.00002. So if you observe, we always give importance to the 4 points or 4 digits after this point or this decimal. So after this decimal, if you consider the 4 points, obviously it looks like a 0. So instead of writing the equality, can you equate this as approximately equal to? See, I am not telling this is exactly equal to 0, but I am talking about it is approximately equal to 0. So now the meaning of this symbol is h is tending towards 0, or h is approaching towards 0. So let me tell you friends, it is not 0, but it is close to the 0. And let's say this is the closest value to the 0, like a 0.00002. And if you observe this after the decimal point with this 4, it's approximately equal to 0, or it's very close to the 0. Now here comes the symbol of approximation. So if you want to remove this limit, if you want to remove this symbol, if you want to remove this h tends to 0, this is not exactly equal to 0, but it is very close to the 0. if this is the LHS and this is the RHS, and let's say if this value is 5, so friends, this value is not equal to 5, but it is very close to the 5. That is the meaning of this symbol. So it's very close to the 5, means it's like 4 point something 9999999. So right, it's very close to the 5. So even we can say this is like a 5.00000002. So this is not equal to 5, but it is very close to the 5. So right, so if I say the left hand side is 5, the right hand side is something 5.0002, and if you observe the 4 digits after the decimal, it looks like equal to 5. But let me tell you friends, because of this decimal point calculations, it is not exactly equal to 5. So that's why here I am interested in removing this symbol. I am interested in removing this symbol, but if you remove this symbol, then you cannot keep the equal to sign. So that's why I am putting here the symbol for the approximation. So instead of equality, please observe, instead of equality I am putting an approximation symbol, and I am removing this symbolic form of the limit, which is h tends to 0, and this entire term f of a plus h minus f of a divided by h. Okay, then please shift this h on LHS. So this is h times f dash of a is approximately equal to f of a plus h minus f of a. Then at the end, this is the term with the minus sign. I am shifting it on LHS. So if you shift this entire term on this side, so I am shifting this term on this side. So it's f of a plus h into f dash of a is approximately equal to f of a plus h, which is nothing but the formula for the approximation. Just do one thing, switch over LHS and RHS, and if you switch over the positions of LHS and RHS, you will get the end result as very interesting one, f of a plus h. I am talking about this as LHS, which is approximately equal to, see, observe this, this is approximately equal to this calculation, that is f of a plus h into f dash of a. So let's highlight this formula, and this is the formula for the approximation. And since there is no equality sign over here, this is just a rough calculation, this is just a rough way of doing the finding of a function value. So therefore this is not the equality, this is the approximation signs. That's why this technique is called approximation. So here we are trying to find the approximate value of the function. This entire explanation was for the students who really want to understand the calculus, really interested in the each and every minute details of the calculus. But as far as problem solving is concerned, let me tell you friends, it is enough to know this formula. So right, so this explanation was entirely for the students who really want to know the details of the calculus, how this formula is derived. But as far as problem solving is concerned, so you can remember this final formula. So let me explain you the way that you have to apply this formula to the various functions to find their approximate value. So please remember this final result, f of a plus h is approximately equal to f of a plus h into f dash of a. So I will explain you each and every details of this formula with this simple example. So let's start with this first simple example. The question is simple. You have to find approximate value of the following function values. So it's a, let's say it's a e raised to 2.1 that you have to find out. So you have to find out e raised to 2.1, and it is given the value of e square. They provided you the value of e square as 7.389. I am giving you the exact value for e square. Okay, so this is the thing. So they are interested in finding e raised to 2.1. We know the value of e square, but friends, we don't know the value of e raised to 2.1. Then how to tackle this situation? So whenever observe the given function, this is actually a function, exact value of the function, but this is expressed in the form of the value, but try to guess the functions. How to guess the function? Just try to observe the value and treat it as an x, and you will observe this is the standard function e raised to x. It looks like a standard function e raised to x. Before that, observe this is the value which is creating the issue, so 2.1. So let's split that value into two parts, one larger one and another one which is very small. So you have to split that value into two parts. One is a larger, another one is a smaller one, and compare this one as x equal to a plus h. And friends, here we got the value of a and value of h that you are observing in the formula. So value of a is 2 and value of h is 0.1. So there is a logic behind splitting this value. I will discuss it in a few problems, but let's try to understand the entire process first, and then we will also discuss the logic behind splitting this term. So we will also discuss the logic behind splitting this term, but just go with the flow, try to understand the process. So a value is 2, h value is 0.1, and most of the values you already got. Okay, then let's define the function f of x. Okay, so here there is a function value present, there is a derivative of value present. If you want to find a function value and a derivative value, you must define a function. And let me tell you a simple way to define a function from this. See, this is e raised to 2.1. This 2.1, hide it and assume it as an x. So what is the function that you are observing? This is like a e raised to x. So friends, here the standard function is e raised to x, and if you observe the formula, there is a function value at a and there is a derivative value at a. So there is a requirement of both the cases, function value as well as its derivative. So let's find the derivative of this. And you know that derivative of f of x or derivative of e raised to x. What is the derivative of e raised to? It's a standard formula. So derivative of e raised to x is e raised to x. We know this formula. So derivative of e raised to x is e raised to x. So here I got the function, here I got its derivative, and your job is to substitute the value of a inside the function and the derivative. We want f of a and f dash of a. So friends, what is the meaning of f of a? So what is a here? It's 2. So means you have to substitute the value of a inside this function. So finding f of a is all about finding f of 2. So because the value of a is 2, so please substitute this value of a instead of x. So let's substitute this value of x. So instead of x, I am substituting this 2 over here. This becomes e square, and e square value is already given to you. Okay, then how to find f dash of a? So finding the f dash of a. So means finding f dash of a value is 2. So means you have to find out f dash of 2. So let's substitute this 2 over here in this function. So this is e square. So finally we got f of 2, we got f dash of 2, and this is nothing but f of a, this is f dash of a, this is a, this is h, and I think everything is ready for this formula. So let's substitute each and everything here in this formula. So f of a plus h is approximately equal to f of a plus h into f dash of a. So friends, f of what is a plus h? A plus h is nothing but x, and which is nothing but 2.1. So this is nothing but 2.1. Overall value of a plus h is 2.1. So here I substituted a plus h value as 2.1. What is f of a? F of a is nothing but this e square. What is h? H is nothing but this 0.1, and this f dash of a is nothing but e square again. So please substitute the value of e square. So value of e square which is given here. So 7.389. This 7.389 plus 0.1. Once again it's a 7.389. Do the calculation. So f of 2.1, that is nothing but the function of 2.1. That is nothing but e raised to 2.1. So this is nothing but the function. And f of 2.1, this is nothing but the function. F of 2.1 is e raised to 2.1. So e raised to 2.1 is equal to this entire calculation. And for you, I already done this calculation. Just cross check later on. I am not wasting the time in doing the calculation. So please calculate it later on. It's 8.1279. So please note down, and you can do the calculation later on. But try to understand the entire process of finding the approximate value of the function. So they will provide you this kind of function along with this kind of values in the decimal, or the values something that we don't know the exact answer for it. Okay, then do one thing. Always hide that value. Consider it as an x. That will give you a standard function. So the standard function is e raised to x. Here I define. Immediately find out its derivative, f dash of x. Derivative of e raised to x is f dash of x. Okay, then just pick this value 2.1 and split it into two parts. One which is a larger, another one which is a very small, and mark this as x is equal to a plus h. Okay, why I splitted that 2.1 as a 2.01? Why not it as a 1 plus 1.1? So why not something else? The reason is quite simple. We know the value of a is equal to 2. If you substitute that over here, we get e square, and e square is given to you. So we want to take advantage of e square. And if you observe, the index of e is 2 over here, and I want to take advantage of that. So that's why I splitted that 2.1 as 2 plus 0.1. So always split this 2.1 or this structure in such a way that we can easily define the given function for this a. So make sure that you can easily define the function value for this a, and if you observe, I selected a as a 2. The reason is quite simple. The reason is the function and its derivative, mostly the function. If you substitute a is equal to 2 over here, which gives you e square, and e square is already given, and I took a benefit of e square. That's why I splitted this 2.1 as 2 plus 0.1. The logic is simple. If split this value into two parts, listen this very carefully. Split this value into two parts such that you can easily define function value for this a. So make sure that the function value is available for this a. You can easily define the function value, or you can easily calculate the function value for that a, and this is the logic to split the given value. Okay, let's understand this approximation. This looks a little bit tedious, but let me tell you friends, with if you face 2-3 problems of this, definitely you will observe that this article is very simple. So believe on me, just go with the flow, face 2-3 problems, and definitely you will enjoy this article. So let's try to find the approximate value of 3 raised to 2.01. So here we want its approximate value, and they provided you some data. They provided you the value of log 3, which is 1.0986. This is given data, and let's try to find approximate value of this structure. Okay, so then this is the problem. So 2.0, let's split it into two parts, 2 plus 0.01. So this is x, compare this with a plus h. So a value is 2, h value is 0.01. So friends, how to define a function? Let me tell you a simple trick. Assume this point or a number which is in the decimal, assume this as an x, that leads to the standard function 3 raised to x. So the function here is 3 raised to x. Immediately find out its derivative, and you know that what is the derivative of a raised to x? This is the standard formula. Derivative of a raised to x is a raised to x into log a. So derivative of 3 raised to x is 3 raised to x into log 3. As per the formula, there is a requirement of f of a and f dash of a. So let's substitute the value of a inside the function. Substituting the value of a means you have to substitute the value of a as a 2. So here I am substituting this as a 2. So 3 square, you know the value. 3 square is 9. This is nothing but f of a. So understand this. Finding the f of a means you have to substitute the value of a as 2. So this is nothing but finding f of 2. So here I substituted instead of x the value 2. So this is 3 square, answer is 9. Okay, let's find the f dash of a. So how to find f dash of a? A value is 2. It's a simple language. You have to substitute a value inside this derivative. Okay, so this is 3 square into log 3. So 3 square is 9 into log 3. Let's keep this thing as it is. Now everything is ready. A is 2, h is 0.01, f of a is 9, f dash of a is 9 times log of 3. Let's apply the formula. Formula is f of a plus h is approximately equal to f of a plus h into f dash of a. So a plus h together is, so this is nothing but x, which is nothing but 2.01, is approximately equal to f of a value is 9, h value is 0.01, and f dash of a value is 9 into log 3. So right, okay, function of 2.01. So this is the function. So right, this is the function, and if you substitute 2.01, that is nothing but 3 raised to 2.01. Symbolically, maths is a symbolic language. Try to crack the symbols. So function of 2.01. So if you substitute 2.01 here, this is 3 raised to 2.01. So 3 raised to 2.01 is equal to, if you solve this one, this is 9 plus 0.01 into 9 into, they already provided the log 3 value, substitute over here, 1.0986, and please calculate and find out your answer. So I already calculated this one to save our time, and please cross check later on whether it's correct or not. It's a 9.098874. So it is up to you. So please confirm this final answer for this question. Okay, so I hope after these two examples you think this article is little bit simple, and if you face one more, then the entire idea of approximation will be very clear. So let's face one more question, but I am changing the function here. This is log of 101. So they provided you the log of 101, and also they provided you the value of log 10 to the base e. Mathematics means base of the logarithm is e, and which is given equal to 2.3026. Most of you already know the log 10 value to the base e, 2.3026. Okay, so we want approximate value of this log of 101. Let's try to find approximate value of log of 101 on the basis of given data. Okay, so how to analyze a function? See, preparing a function is a very simple job, friends. So to obtain a function, you know that this is the value which is creating a double. We don't know the exact answer of log of 101. So this is the value which is creating double. Assume this as x. Assume this as x. So this is log x. So the function here is log x that you already know. So the function is log x, right? Immediately find out its derivative. So what is the derivative of log x? It's a standard formula. Derivative of log x is 1 upon x. You already know the formula for derivative of log x, which is 1 upon x. Okay, then the next job is the split up of this value. So let's split this 101 as 100 plus 1 and ask yourself why. Why we are splitting this 101 as 100 plus 1? Why not like a 99 plus 2? Why not 100 plus 1 as a 10 plus something? Or why not something else? Why we are splitting this 101 as 100 plus 1? The reason is quite simple. This is x, this is a, this is h. So what is a? A is 100. And we can easily define the function for 100. So log 100. See, always make sure whatever is the split up, we are not at all interested in the value of h. We are always interested in the value of this a. This a value is very important. Make sure that you prepare this a in such a way that you can easily define the function and its derivative for that. Right? And so this wording is very important. Please listen it very carefully. Split this value into two parts such that this a easily defines the function and its derivative. Okay, so let's try to find f of a. A means 100, substitute here 100, so it's a log of 100. And so many of you will ask me, sir, log of 100 is not known. But friends, log of 10 is given. So let's apply some trick. So 100 is a 10 square, and this is the formula for the logarithm. Log of m raised to n is n into log m, and log of 10 is already ready with you, so we can easily substitute that. Okay, then what is f dash of a? So please understand, f dash of a means you have to substitute the value of a, which is 100 over here. So if you substitute 1 upon 100, it is 0.01. So right, so here we got f dash of a. So the entire data is known to you now. What is the value of a? A is 100, h is 1. So a is 100, h is 1. F of a is twice of log 10, f dash of a is 0.01. Let's substitute in this formula. So f of a plus h is approximately equal to f of a plus h into f dash of a. So f of a is this one, twice of log 10 plus h value. In this case it is 1, and f dash of a is 0.01. So just substitute the log 10 value, which is given as 2.3026 plus this is 0.01, and I am keeping rest of the calculations for you. Please do the part and be ready with the answer. So we will cross check. So I'm giving you the 10 seconds, so friends, be quick, solve this and be ready with your answer. Be ready with your answer. And we will cross check. So I already calculated answer for this. So let me tell you friends, I am interested in the concept but not in the calculations. So calculation is not a purpose of this video. The purpose of this video is the knowledge, skill and understanding the theme behind the problem. So I already calculated for it. So just cross check whether it's a 4.6152. I hope most of you are already correct with this value. Okay, so then one more example for your understanding. So let's say we want to find value of tan inverse of something 0.999. So please observe, I am constantly changing the functions. I am changing the functions so that, see, this approximation technique is very common to all the functions. The function may be algebraic, it may be trigonometric, it may be exponential, it may be logarithmic or anything else. So you can apply this approximation technique for any kind of function. So here if you observe, this is inverse trigonometric function tan. So it's a tan inverse 0.999. So very interesting one. This is very important problem. So how will you split this 0.999? So you have to split this as a plus h. And my question is, how will you split? The h is not more important one for us, but the a is. Okay, so to define this a, let's define the function first. What is f of x for this question? See how to obtain the f of x. Do a simple job. This is 0.999. So for this 0.999, let's assume this as a x. Let's treat this as an x. So this becomes tan inverse x. So let's assume this 0.99 as a x that leads to the tan inverse x, which is a function. Immediately find out its derivative. It's a standard derivative. You know the formula. Derivative of tan inverse x is 1 upon 1 plus x square. So derivative of tan inverse x is 1 upon 1 plus x square. Okay, the function is ready. Its derivative is ready. But your answer is pending. How will you split this? 0.999. Okay, so once again I am repeating the same sentence. Split that 0.999 in such a way that this a, this value of a is very important friends. So obtain the a such that you can easily define the f of x and f dash of x. Make sure you can easily define the value of f of x and f dash of x or the derivative for that corresponding value of a. So you have to split this 0.999 in such a way that we can easily define f of a and f dash of a. Okay, so if you remember, if I split this 0.999 as 1 minus 0.001, so what will happen? If you substitute 1 minus 000, let's say, and if you subtract 0.001 from it, so what will happen? So this is 9, this is 9, this is 9, this is 9, 0.999. So there is, I think there is one more 9 that is given, so it's a 0.001 more 0 and 1. Okay, so this is the split up. Let's say 1 minus 0.00001. 1 minus 0.0001. Okay, so here I split it. It's not with a plus sign, but compare it with this. A value is 1, and what is h? H is minus. See, h may be positive or negative. We are not at all interested in the h. We are only interested in a, and you can split the given value in the form of plus or in the form of minus. It doesn't matter at all. What matters is, can we define the function value and its derivative for this a. This is all what matters. So therefore, value of a in this case is 1, but the value of h is a negative minus 0.0001. So right, okay, so then as per the formula, we require f of a. So what is a? Which is 1. Substitute over here. So finding the f of a is finding the f of 1, because a is 1 and you know the value of tan inverse 1. So we already discussed inverse trigonometric functions in my previous video. I hope every one of you know the value of this. Answer for inverse is angle. So right. So tan inverse x is always theta. So answer for A inverse is always an angle. If you want to find tan inverse 1, try to guess which angle of tan leads to the value of 1. So and you know that tan of 45 degrees is 1. So therefore answer for this is 45 degree. So tan inverse 1 is 45 degree. In radian it is pi by 4. Let me explain you. So don't use the degree system because everything is in the form of digits. So please use radian system. So tan inverse 1 is 45 degree, but don't mention it in the form of degree. Please mention it in the form of radian. So answer is pi by 4. Okay, what is f dash of A? So finding f dash of A means you have to substitute the value of A, which is equal to 1. So 1 upon 1 plus 1 square, which is 1 by 2, and you know that 1 by 2 means 0.5. Okay, so each and every ingredient is ready for our formula. We know the value of A, we know the value of H, we know f of A, this is f dash of A. Let's substitute everything in the formula. So f of A plus H is approximately equal to f of A plus H into f dash of A. So f of A is pi by 4 plus H. So please observe H is a negative in this problem. So it's a minus 0.0001 into f dash of A, which is 0.5. So your final answer for this question is pi by 4 minus 0.0001 or 0 and then 5. So please cross check. This might be your final answer. If you want, you can substitute the value of pi, which is 3.142. So and after that, even you can, if you want, you can simplify. But I will suggest keep this thing as it is, and I hope every one of you got the answer for this one. And the reason is why I splitted this 0.999 as 1 minus 0.001. This is very important. The reason is quite simple. I am not at all interested in H, but I am interested in this A value, which is 1, and we can easily define the function and its derivative for this one. That's why this is the reason behind splitting this value into two parts, or splitting this value in this way. So the most critical part or the interesting job is to split that value. So right, as per the requirement of the formula. Okay, one more for your understanding. So I am changing the function, my friends. So let's switch to the trigonometry. So let's say it's a sine of 61 degree, and they already provided you few information. They provided the value of 1 degree, which is 0.017174. This is given, and they also provided the value of root 3, which is 1.732. On the basis of this given information, you have to find the approximate value of sine of 61 degree. Okay, so how will you tackle this 61 degree? So my question is, how will you split this 61 degree in the form of A plus H? To guess that, first of all, define the function. So let me tell you, friends, writing a function is a very simple job in this kind of problem. This is the value that we have to crack. Just assume this portion of the problem as x, that leads to the standard function sine x. So friends, this is nothing but sine x. This is the original function. And you know the derivative of sine. Immediately find out its derivative. Derivative of sine x is cos x. You know that derivative of sine x is cos x. Okay, then just guess how will you split this 61 degree into two parts, and always give importance to this A, and split that into two parts such that in such a way that you can easily define the function and the derivative for this A. This is the important thing. We have to give very important importance to this value of A, and split this 61 so that whatever is the A, you must be able to define easily the function and its derivative, because this is the requirement of the problem. Okay, so how will you split? I hope every one of you is ready with this. We can easily split this 61 degree as 60 degree plus 1 degree, and splitting this 61 degree as 60 degree plus 1 degree. Why? The reason is quite simple. We know the value of sine 60, even we know the value of cos 60 degree. So these are the familiar values, so we can easily find out. So finding f of A means A value is 60 here, so I am substituting 60 over here. So this is sine of 60, and you know that sine 60 is root 3 by 2. Okay, let's find f dash of A. So finding f dash of A means substituting the value of A, which is 60 degree. So this becomes cos 60, and you know that cos 60 is 1 by 2, and 1 by 2 means 0.5. So everything is with you now. So A value is 60 degree, H value is 1 degree. So right, so let's write everything in the form of formula. So f of A plus H is approximately equal to f of A plus H into f dash of A. So let's substitute the value. So what is the f of A value? That is this one, which is root 3 by 2, plus what is the value of H? So friends, H value is 1 degree and f dash of A is 0.5. Are you observing something? There is a one issue with this problem, that is nothing but this degree. See, this 0.5 is ordinary digits in radian, this is root 3 by 2, which is also in radian. So you just always keep the uniform units inside any problems, whether it's a problem from the physics or chemistry or from the mathematics, whatever may be, you must keep always a uniform units. Okay, so this is a simple in radian, this is in radian, so we cannot keep this 1 degree, but they already provided the value of 1 degree, which is 0.0175. Also substitute the value of root 3 over here, so it's a 1.732 divided by 2 plus, and replacing this 1 degree using 0.0174 into 0.5, and the rest of the job is with you people. So quickly find out this answer and cross check with this 0.8747. Just cross check whether your final answer is exactly equal to this or not. So I hope you got this question of finding approximate value of sine of 61 degree also. So if you are observing, in my first problem I covered the exponential function. In the second problem we covered logarithmic function. Then we covered inverse trigonometric functions. The next one is trigonometric function. See, I can change the functions every time. But what is your observation? The entire process remains same. Splitting the value into the A plus H, we can say this is the step number 1. Defining the function value, 2. Defining the derivative value, 3. And expressing it in the form of this formula that leads to the approximate value of the given function. So right, every time you have to follow these 4 steps. Splitting up, 1. Defining the f of x, finding its derivative, and at the end substituting in the formula. So this is a simple 4-step procedure for approximations. Okay, so let me cover an algebraic case that we still not yet covered. So let's try to find the approximate value of 8.95. So let's try to find approximate value of under root 8.95. Okay, so let me define the function first. How to define the function, friends? It's very simple. This is the value that you have to crack. This is the value that you have to split into 2 parts, like a plus h. So treat this as an x, and you can easily guess the function. The function is root x. So function is root x. What is its derivative? So derivative of root x is 1 upon 2 root x. We know the derivative. This is the standard formula. Derivative of root x is 1 upon 2 root x. Okay, then how will you split? The real question lies here. This is the most tricky part. How will you split this 8.95? So right, make sure you split that into 2 parts. One is the larger one is a very small, but always gives importance to this a, not to the h. Always gives importance to the a. And make sure that you define this a in such a way that it easily gives you the value for this function and its derivative. You can easily define f of a and f dash of a. Make sure that while splitting this value. How will you split this 8.95? So obviously you can split any value in the form of plus or in the form of minus. Both the cases are possible, and splitting this in the form of minus, like a 9 minus 0.05. So right, so I am splitting this as 9 minus 0.05. That leads to 8.95. So right, okay, so let's assume this as a x is equal to a plus h. So a here is 9 and this h is minus 0.05. So here I got h, here I got a, and let's define f of a. Finding a f of a means substituting this value of 9 inside this function. And are you observing why I splitted this into the 9 minus something? The reason is quite simple, and it lies somewhere here. Its answer lies somewhere here. You know the value of root 9, and root 9 is 3. This one was the reason. That's why I splitted this value as a 9 minus something. So right, the importance was to the 9 because we can easily define the under root 9 value, which is 3. Let's substitute over. So this is f dash of a. So finding an f dash of a value is 9. So it's 1 upon 2 into under root 9. 1 upon 2 into under root 9 is 3. This is 1 by 6. Okay, all the ingredients are ready with you. A is known, h is known, f of a is known to you, and at the end f dash of a is also known. Let's substitute in this formula. So f of a plus h is f of a plus h into f dash of a. So f of a, so this is function of a plus h, means I am talking about this under root 8.95 because we are trying to find approximate value of that function. What is f of a? F of a is this one, which is 3. What is h? This is in the form of negative minus 0.05. And f dash of a is 1 by 6. And keeping the calculations up to you, please simplify and find out. So it must be less than 3 or something. So I hope you are ready with your answer. So please cross check it with 2.9917. Okay, so if you observe this entire application of this derivative called approximation technique, so I'm constantly changing the different types of functions like exponential, logarithmic, trigonometric, inverse, algebraic, anything. So don't worry friends, the process never changes. Every time if you observe, I am following the 4 steps. This is very important one. This is the entire summary of this article. Just follow 4 steps. The step number 1, split up of the value. This is very important one. Splitting the given value. And make sure that you split it into 2 parts. One is a larger one called a, smaller one called h, and you can split that value into either in the form of plus or in the form of minus, both the ways. As per the requirement of the problem, you can take the decision, but make sure that you give importance to this value of a because everything depends on this a. Make sure that you define this a in such a way that you can easily define the function and its derivative. So this is the step number 1. Step number 2 is defining the function value. How to define a function? Just simply put a x instead of that value that will lead to the function. So this is the function. You can easily find its derivative. Obtaining a derivative is 3. In this function, substitute a, that will lead to f of a. In this derivative, substitute a, that will lead to f dash of a. So splitting the values, step number 1. Finding f of a, step number 2. Finding the derivative of a, so that is step number 3. And step number 4 is our important formula of approximation. That is f of a plus h is approximately equal to f of a plus h into f dash of a. I hope this entire explanation, 4-step procedure of this approximation is now clear to everyone. Now whatever may be the type of problem, whatever may be the function or the value they will provide, you can easily crack the problem on approximations. So many times the students ask me the question, in this world of computers and in this world of scientific calculators, is there a really need of this kind of technique? But let me tell you friends, those who are preparing that software, those who are preparing all the software things behind finding these approximation values, whether it's a scientific calculator or whether it's a computer, that programmer knows this technique, so then and then only he can create that particular software. So always gives importance to the process, right? You have a computer or you may have a scientific calculator, but the data behind or the coding behind that software always lies somewhere here in the mathematics. So always gives importance to the any process irrespective of the gadget that you have. I hope you enjoyed this session on finding approximate value of the functions. In next session we will see one more application of derivative. Till then, goodbye, take care, please like and share with your friends. Thank you.